All right, so this packet gives us 2 problems to practice FRQ number 1 and 2 problems to practice FRQ number 2. So before we get into it, looking at the 3 practice tests that we have, it looks like the first part of number 1 is always going to ask us about a composition. So here's the composition we've been given. They do give you that full formula, and then they give you like a table or a graph for the inner function, and then the outer function has always been an equation. So if we take a look at number 1, f of x is given to us as a table. G of x is this equation. We want to find h of 3 as a decimal approximation. Remember that problems 1 and 2 are calculator allowed. It will always be like that. You're going to be given 30 minutes to do the first 2 problems, and then they'll have you stop, and then you'll get 30 minutes to do the last 2 problems. All right, so anyway, h of 3. You need to show work for these, even though you really just get your point for the answer. It's sort of like work and answer. So h of 3, follow this formula, equals g of f of 3. So the input for h is the input for f to begin. So use the table. F of 3 is equal to 2. So now we simplify this. G of f of 3 is now just g of 2. 2 needs to get plugged into g's function and for those x's right there. So g of 2 is equal to 2 plus 3 over 2 plus 2. So h of 3 is equal to 5/4. Now be careful. Even though in class we would leave our answer like this, the directions say to find h as a decimal approximation. So you do need to say it's 1.25. Which is not really an approximation. That's just the decimal version, but still. Part of what I think they're grading there is just, can you read directions and give the answer how they want it? Find all values of x for which g of x equals 12, or state that there are no such values. So again, show some work here. So what this means is, it shows us right here, set g of x equal to 12. So set x plus 3 over x plus 2 equal to 12. Now you have your graphing calculator, so you could put this into your graphing calculator and solve, or this one's not bad to do algebraically either, so I'm going to show you both ways. When I want to put g of x into my graphing calculator, I go to y equals, make sure that you put parentheses around x plus 3 over x plus 2, and then in a different line, put in the number 12. Now, if we just do Zoom standard, you could always kind of start there and see if that's good enough. But remember, we're trying to see when this is equal to 12. So I can see the g of x graph, but I need to bump the window up a little bit to fit 12. So maybe I'll just push it up to like 15 just so I get a clear view, and then I'll press graph. So you need to be able to see the intersection point for the calculator to find it. So second, trace, intersect. Here's the cursor. Is this one of the curves? Yes, press enter. Is this one of the curves? Yes, press enter. Guess, press enter. Round to 3 places. If you do all of this and you round to less than 3 places, you will not get credit. So x is approximately equal to negative 1.909. Now, if I were to solve this algebraically, so I can just, this can be it for my answer. And the work that I showed was just setting up the equation. I could also do this by hand. So if I'm solving this equation, I would need to multiply the x plus 2 over to this side and distribute the 12. And then get your x's together and get your non-x's together. So again, you would need to change this to a decimal, but we can, this is a good way to check your answer too. Maybe having 15 minutes per problem leaves you with extra time. You can go back and double check things. So I did get the same answer this way as I did with the graphing. Be careful of little things, like make sure you didn't, I almost forgot to write the negative sign, again, rounding, just make sure that if you have time left that you're checking your answer. Part B, part 1 says find the value of f inverse of 2. So this does not mean 1 over f. This means f inverse, or state that it doesn't exist. So what does this mean? Remember, this means that f inverse of 2 means does f of x have an output of 2? And if so, where does that happen? Or that's kind of confusing, right? So you could make an f inverse table if you want. We could do this, x, f inverse of x. The f inverse table would just be flipping all of these, so the y's become the x's, and the x's become the y's. That's a little bit easier to see, right? And then what's f inverse of 2? When I put 2 in, I get 3 out. Or from here, if you don't want to write a whole table, I could say something like this. Since, now again, you don't have to justify, but just I kind of like to if I need to. So since f of 3 equals 2, flip that around, f inverse of 2 has to equal 3. So whether you need to make an f inverse table by just switching x's and y's, or if you can do it this way, like find where f of x is equal to 2, and then that's your answer, that's fine. It would not exist if there was no output of 2 for f of x. Determine the end behavior of g of x as x increases without bound. Remember, that means as you trace x toward infinity, or as you trace to the right, where's the graph going? Your only choices for this end behavior stuff are infinity, negative infinity, or a horizontal asymptote. So if you're not sure, g of x is a rational function, but if you're not sure, remember you can graph it, which we already did for a previous part. So all this is saying is if you're on the blue curve and you trace toward infinity for the x values, so you just keep going, 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 what number are we approaching? So you can have this, use this graph to help you. But remember, we know about rational functions. So the rational function g of x is equal to x plus 3 over x plus 2. Remember, that's a tie. Now, none of this is official AP stuff, but just how did we speak about this? This is a tie. We have the same exponent in the top and the bottom. So those will, in the long run, divide out to 1 because it's 1x over 1x. If this were 2x in the bottom, it'd be 1/2. So there is a horizontal asymptote at 1. Now, the next thing is make sure you have the exact correct limit notation, because it says express your answer using the mathematical notation of a limit. So it's limit as x approaches infinity, because it says x increases without bound, of what? Of g of x, or you can write x plus 3 over x plus 2 here, equals, what does it equal? It equals 1. Don't put an arrow right here. Some of you keep putting arrows right here. Some of you are using the old notation from Algebra 2. It's got to be limit notation, which we have in our study guide. Just kind of a point of memorizing it at this moment. All right, use the table of values of f of x to determine if f is best modeled by linear, quadratic, exponential, or log. What are we supposed to do here? Remember, this is where you have your table and you can find the first average rate of change or the first differences. If those are constant, then you have a linear function. If the second average rate of change, differences, if those are constant, quadratic. If you can divide consecutive y values, if the y's have a common ratio, like you divide the y's and you keep getting 2 or 3 or 1/2 or whatever, if the y's have a common ratio, it's exponential. And we didn't talk about this a ton this year, but if the x's have a common ratio, so if there's no pattern with the y's, but the x's are being multiplied by 2 or multiplied by 1/2 or whatever, if those have a common ratio, then it's a log function. So let's take a look at this. Also, remember, you have your graphing calculator, so you could also look at it and see like what shape does it kind of look like. So I'm just going to copy the table down so that I have something to work with without scrolling up and down. So the x's go 2, 3, 4, 5, 6. The y's are -1, 2, and 7, and then 14 and 23. Now, first and second differences are okay to say, but you do have to pay attention that the x values need to change by 1. I would rather just say average rate of change, so I don't have to talk about equal intervals between x values and all of that. So I'm just going to find the first average rate of change between these points. So that would be like 2 minus -1 is 3. divided by 3 minus 2, which is 1. So the first average rate of change between these 2 points is 3. And then the next average rate of change between the points at 3 and 4 is going to be 7 minus 2, which is 5, over 4 minus 3, which is 1. So I already know it's not linear because this is not constant. The next average rate of change is 14 minus 7 over 5 minus 4, 23 minus 14 over 6 minus 5. So not linear. Now check the second average rate of change. That just means find the average rate of change between these points. So 5 minus 3 is 2 over 4 minus 3. 7 minus 5 is 2 over 5 minus 4. 9 minus 7 is 2 over 6 minus 5. So those second average rate of changes are constant. So this is what is this best model by? Quadratic. What if these were not constant? Then I would go back and check, what if I divide consecutive y values? So what's 2 divided by negative 1? What's 7 divided by 2? What's 14 divided by 7? So if I had a common ratio that way, exponential, or if that weren't the case, if I saw in the y's, or in the x's, I could do 3 divided by 2, 4 divided by 3, 5 divided by 4, and look for a common ratio in the x's for it to be logarithm. This is a quadratic model. Now, I did my work up here. It says give a reason for your answer based on that relationship. So the reason needs to be more than just the table anyway. But remember, this part C is always like part 1 is just an answer, and then part 2 is explaining. So explain what your table shows you. I would say the second average rates of change are constant. So f of x is best modeled by a quadratic. And remember, if you have more choices, if it's the third differences, third average rate of change, it's cubic, fourth, quartic, etc. I don't think they would give us much higher degree than that. All right, what about our second problem number 1? So ignore this, that's typo. Okay, f of x is graphed below, and g of x is this natural log equation. So again, here's another composition. We need to find h of negative 3 as a decimal approximation. So set it up first. H of negative 3 should equal g of f of negative 3. Always start on the inside. What is f of negative 3? So here's the f of x graph. Go to negative 3. Where are we on the graph? F of negative 3 is 7. So now the problem simplifies to what's g of 7? G of 7 has to go into our calculator. Natural log of 2 times 7 is 14 minus 8. And again, we're putting this in our calculator. I don't want to make a silly subtraction error. It is natural log of 6, but I don't want to do something silly there, so I'm just going to type it in as it is. So natural log of 14 minus 8. So it's about 1.792. You have to round to 3 places. Even if you have the correct statement here and then you round incorrectly, or you round this to 1.8 or 1.79, you don't get credit. You have to follow directions. At the beginning of the test, on the page that you might have skipped over and not read, it tells you clearly to round to the nearest thousandth, which is 3 decimal places. All right, find all values of x for which f of x equals 2, or state that there are no such values. So f of x, we're still on this graph here. When is it equal to 2? So basically, what are these points? Here are 2 points where the y value is 2. So what x's make those happen? And there's not really work to show here, so I would just say f of x, this is one of those like restate the question, f of x equals 2 when x equals, I bet we could write plus or minus 2, but I'm just going to be safe and write it out. Just kind of think like you're writing something a little more formally for the AP test. So when x equals negative 2 and 2. Let's not use commas to separate our answer, because depending on your handwriting, and some of you know about your handwriting, if you put a comma there, it looks like negative 2.2. And so you have to be careful of that. So let's not separate our answers with commas unless it specifically says to do that. find all zeros, remember zeros are x-intercepts, of g as decimal approximations or indicate that there are none. So remember g, not f. So this is asking when is ln of 2x minus 8 equal to 0? Now remember, you have a graphing calculator, so every time you're supposed to solve an equation, you can just graph it and solve it. And that's kind of a nice skill so that you don't make a small mistake, or if you don't remember how to solve a certain type of equation, we can get around that. So we can type in ln of 2x minus 8, and I like to just type in 0 so I can just find the intersection instead of finding the zeros using the calculator. What about the graph? So for these where the domain is not specified, I like to just zoom 6 and see what it looks like. So here's the graph. Now the graph does continue on. It's just, remember, the graphing calculator can only be so accurate to a degree, so it does continue down. There's a vertical asymptote there. Here's the intersection point. We just have to find it. So second, trace, intersect. And then make sure, see how it's not really on the first curve? Make sure you can see your cursor. Move to the right, because right now we're at x equals 1 point something. We need to scooch it out there until we get to something defined. There we go. So yeah, here's one of the curves, enter. Y equals 0 is the second curve, enter. Guess, enter. 4.5 exactly. So this is x equals 4.5. Again, as a decimal approximation, so keep it like that. Now, maybe your graph is being tricky or you're not sure, you've got your stat plot on, you can't figure out why it won't graph and what's happening. You can solve this by hand too. Remember, if I want to get rid of a natural log, I can base e both sides. E to the ln of 2x minus 8 equals e to the 0. E to the ln, those are inverse functions. They cancel each other out. E to the 0 is 1. And so you do get 9 over 2 this way, which is 4.5. So either method is fine. They don't have a required type of work that you show. You just need to show something. So show your equation and find on your calculator, or show the math here and find the answer that way. Determine the end behavior of g of x. Pay attention to which function it is. As x increases without bound, x is going to infinity again. Express your answer using the mathematical notation of a limit. So again, we have to have the right limit notation. The limit as x approaches infinity of what function? G of x is equal to what? So if you haven't graphed ln of 2x minus 8 on your calculator yet, you should do so. Now, I do think that you should know what an ln graph looks like, but remember, with transformations and things like that, just to be safe, if you're allowed to use a calculator, just use a calculator. So here's the red graph again. Now, some of you on your practice tests previously were thinking there was like a horizontal asymptote here. ln x does grow. It does increase without bound. It's going to keep getting higher and higher. It just does it very slowly. So there is no horizontal asymptote here. So what is this going toward? Because it's increasing without bound, g of x is heading to infinity as you trace it out to the right. That's it. You don't need to sketch the graph. You don't need to explain yourself. Your only options for these questions are infinity, negative infinity, or a horizontal asymptote. Determine if f has an inverse function. Now, f is the graph. Yes, it's failing horizontal line test. So I'm going to say there is f has no inverse function. I've been accepting yes or no answers here, but I think it's probably nicer if we write a sentence just to be safe. So f has no inverse function. Give a reason for your answer based on the definition of a function and the graph of f of x. You're not allowed to say because f fails the horizontal line test. That's what you should be quickly using in your brain to decide yes or no. But we have this on our study guide. What is the official answer to this? Either say f of x is not 1 to 1. Write out the words 1 to 1. Do not do 1 to 1. That looks like the absolute value of the word 2. Okay. F of x is not 1 to 1. Or the definition of a function here is saying like f of x. Again, make sure you're not saying it. So f of x has, or actually let's say this just to keep it kind of consistent with the study guide. Our study guide, let me show you what our study guide says about this. Excuse me. Okay, here we go. Excuse me. F of x, let's see. Here we go. F of x is not one-to-one because there are multiple inputs for some outputs. Or you could also say, I have this on today's at the bottom here. What else could we say? Does every output have exactly one input? So I could say f of x doesn't have exactly one input for every output. Now, you could also say, I'm kind of complicating that, I think, but you could also say some outputs have two inputs. Or you could use an example, f of negative 2 equals 2, but that also equals f of 2. So I think there are a lot of ways you could answer this. Definitely put the, is f one-to-one or not? That's, to me, that's the answer. They include that in their scoring guidelines from what I've seen. But if you want to be more thorough, you could do this. Just be careful of your wording. So reminders for question 1. You have to round to 3 decimal places. The number of points that have been lost on our practice test just for kind of like not rounding to 3, when that's what we've done all year, drove me a little bit crazy, but that's okay. You've all passed your practice test so far. So again, some of you, if you were on the border between a 3 and a 4 and a 5 or whatever, just round to 3 places. Show work. Especially if the problem says, show the computations that lead to your answer. If you don't show any work, you're not getting credit for it. If there's no work to show, just restate the question, write a sentence, make it look nice. Avoid the word it to replace f of x and f inverse. So like, do not say it's not one-to-one or it doesn't have one input for every output. If you just say it, we don't know if you're talking about f of x or f inverse, and they won't give you the point for that. And then again, I already said this, but we cannot use vertical and horizontal line test as the reason. If you write it on your paper, it doesn't count. It's not that you can't write it down, but it doesn't count. You have to put, if they're asking is f a function, every input has exactly one output. But the question they keep asking us is right here. Does f have an inverse? It has an inverse if every output has exactly one input. That is the horizontal line test, just in words. All right, what about question 2? Question 2, again, is still a calculator question. And this question, they start by giving us either some data points or they'll give us a table with data points. And the first thing we always have to do is write a certain number of equations that are in terms of A and B, or maybe A, B, and C, or sometimes they'll give us 4. We haven't seen that yet, but sometimes they could give us a D as well. Let's take a look at that. In a research experiment, a population of fruit flies is increasing according to the exponential model. So they tell us what kind of model to use. And we have 2 points. After 2 days, there are 100 flies. After 4 days, there are 300 flies. Use the given data, that is the point 2, 100 and 4, 300, to write 2 equations that can be used to find the values for constants A and B in the expression for P of T. You don't have to do any rearranging, just plug in T and P of T. So what's one equation? P of T equals A times B to the T. So 100 equals A times B to the second power. What's another equation? 300 equals A times B to the fourth. That's it. I know the first time we did a practice test, we started rearranging and solving for these. But then when I saw the videos of some teachers going through their scoring guidelines on AP Classroom, they said we're allowed to use regression. So there's absolutely no reason to work on this any further. Just write this down. Find A and B as decimal approximations. So again, you don't need to do this algebraically. I would discourage you from doing that because if you round an answer or if you type something in wrong, that's it. Here's what I would do. Using, in this case, exponential regression, you do need to show, I believe that you do need to show something. Write the sentence using exponential, quadratic, linear, whatever it tells you, whatever kind of model it is, using exponential regression, A is about equal to and B is about equal to. Okay, so how do we do regression? Go to stat, edit, type in the 2 points they gave you. The t values are 2 and 4. The y values are 100 and 300. And then we go to stat, arrow over to calc, find exponential regression. It's toward the bottom. It's option 0. This should say L1 and L2. If it doesn't, if it says something else, you do second 1, second 2. Always store the regression equation into your y, because you might have to use this model to predict something and you don't want to use rounded values. So how do I store that? Alpha trace brings up this list and I press Y1. Okay, now we're allowed to round to 3 places here. So we're allowed to say 33.333 and B is 1.732. Okay, and now that I'm looking at that, sorry, I want to check my answer key that I posted because those are not familiar numbers and I'm wondering if I typed it in wrong on my key. Yeah, oops, I put in 3. Okay, I'll fix the key. Sorry. All right, anyway, this is correct. So these are the 2 values for A and B. You don't have to show algebraically how you get those. Okay, now use the given data to find the average rate of change, the number of flies and flies per day from 2 to 4. Express your answer as a decimal approximation. Show the computations that led to your answer. Here's what you should just show every time. What is our formula for average rate of change? You'll do this in calculus next year too, and you might even get a point for writing this down in calculus. All right, so our model is P. So P of 4 minus P of 2 over 4 minus 2. Use the given data. Do not use the model values. Use the 2 numbers that we have. So 300 minus 100 over 4 minus 2 is 2. 200 over 2 is 100. Excuse me, sorry. Flies per day. I was going to sneeze there. Okay, so that's our average rate of change, 100 flies per day. Use the average rate of change found in part 1 to estimate the number of flies on day 10. Again, we've had this a few times. This is something else to study if you have not gotten this right on your last couple of tests. This is saying find P of 10. Use this little linear equation to do it. So what is a linear equation? Let's start. I like to start at the number that's closer to the approximation. So I'm not going to start at 2. I'm going to start at 4. So P of 4 plus the slope, which is the average rate of change, times the difference in x values between 10 and 4. All right, visually, here's what you're doing. Start at P of 4, travel the slope, land at P of 10. That's all that you're doing. Okay, so P of 4, again, from the given data, not from the model, is 300 plus 100 times 6. That's 900. So P of 10, the prediction here is 900 flies. It's a lot of flies. All right, compare this model. Compare the estimate given in part 2 to the estimate provided by the model. So let's see what P of 10 comes out to via the model. Let's just do that first. Remember, we stored the model in Y1. So on your home screen here, you can say Y1 of 10 is 8,100 flies. All right, so then if that's the case, we want to compare that. That's definitely a lot higher than the approximation. We talked about this in class today. What do we have to show? It says using the characteristics of the exponential model and the average rate of change, explain why these two differ. Always sketch this graph. If you need to be able to sketch the graph, now you can set your window up. So we're going from like 0 to 10, right? And then we could zoom fit. Actually, let's go a little bit past 10 because that's our approximation. Let's go 0 to 15 and we can zoom fit to see what this looks like. So you might not have needed to sketch that to know, oh yeah, it's an exponential model. So it's increasing like this. So here's P of t. Now remember, this slope was between the points that connected, the slope back here was between the points that connected 2 and 4. So here's the average rate of change. If you extend that out to 10, I can see that the line is much lower than whatever the model predicts for P of 10. So here's what I would say. I would sketch this graph, and I would say for t values greater than or equal to 10, because we're looking at 10 here, the P of t exponential model increases faster than the line between t equals 2 and t equals 4. Therefore, the model value is much higher. Something like that. I think sketching this graph and showing that, writing down that the exponential model is much higher than the line ought to be enough about why those two things are different. Should the researchers believe that the model for P of t is more reliable when predicting the population on day 3 or day 10? Well, we can see that the prediction model is a lot different than what we got here for day 10. It's not about which one you think is correct. Do you think 900 versus 8,100 is correct? This is a domain question. So the model is more reliable. It's always on the day that falls between the two data points you were given. So it's more reliable on day 3 because this fits in the domain. And I would just make a note, the domain of like 2 to 4 used to create P of t. And then let's say something about 10. T equals 10 is outside of this original domain. There's always something about a domain, whether they're asking you to find it or explain about it. Okay. All right, let's do one more, number 2. So here we have a table. The table gives the area in square meters of a rectangular region with a length x meters. The area of the rectangular region, a of x, can be modeled by this quadratic function, where x is the length of the rectangle in meters. Use the given data to write 3 equations that can be used to find a, b, and c. So just like I did in the last one, we're using these 3 points. These are ordered pairs, right? So all you have to do is take them in order. 332 has to equal a times 16 squared. You don't even have to simplify that. Plus b times 16 plus c. That's it. Leave that one alone. Write the next one. 325 equals a times 25 squared plus b times 25 plus c. That one's done. And the last one is 291 equals a times 26 squared plus b times 26 plus c. That's it. You don't have to rearrange these because we're going to use regression for the last one. Find a, b, and c. So do not do this by hand. It's really ugly and horrible to do by hand. So instead, I would say using, now I'm not going to do exponential. This says quadratic function. So using quadratic regression, you'll never have to guess at what kind of regression. Just read the problem and see what kind of function it is. Using quadratic regression, a equals b equals c equals Okay, so how do we do this? Stat, edit. Clear out the old list. So go up to the heading, press clear, press enter. Press clear, press enter. Type in your X values, 16, 25, 26. Type in your Y values, 332, 325, 291. Stat, calc, quadratic regression this time, which is number 5. Oh, my pen stopped working. There we go, number 5. L1, L2, store the equation in case we need to plug something into it, or in case we want to look at the graph. We want to do both. And now you're allowed to round these to 3 places. So negative 3.322, 135.433, negative 984.444. Okay, these are the values for A, B, and C. Use the given data to find the average rate of change in square meters per meter from 16 to 26. Express your answer as a decimal approximation. Show the work. So this work should look identical. You're just changing out numbers and calling this one A of X instead of P of X. So A of 26 minus A of 16 over 26 minus 16. Use the given data, again, the table, not your model. So what was A of 26? It was 291 minus 332. And then 26 minus 16 is a difference of 10. 291 minus 332. Divide that by 10, negative 4.1. Now, square meters per meter. I know that simplifies to meters, but just leave it like that. For most of these, if they give you the label, they're not going to require you to write the label in, but that's a habit you should get into for calculus, of always labeling your answer. Use A of 26 and the average rate of change to estimate the area of the enclosure when X is 30. So again, this setup is the same as what I used before, but this time they tell you specifically to use A of 26 instead of giving you the choice to use either one. So start at A of 26, add the average rate of change to that, times the difference between 30 and 26. Again, what you're doing is saying, I'm going to start at 26, I'm going to go the slope, which is negative, and I'm going to land here at 30. You don't have to draw that. Some of you are having a hard time remembering what this is, and maybe if you see the visual for it. So at 26, A was 291. We're subtracting 4.1 times the difference of 4 there. 291 minus 4.1 times 4 is 274.6. So that's the approximation for the area, which would be measured in square meters. Using characteristics of a quadratic model and the average rate of change, explain why the approximation for A of 30 using the model is, I changed this in class today, is lower than the approximation for A of 30 found in part 2. Again, this part B, 3, you should always be sketching the graphs. So if you haven't looked at the graph for A of X yet, do that. You can go to your window and kind of think about the X values, right? We're going from 16 to 26 in the window. So I always like to bump it out a little bit. Let's go like 14 to 30, and then we'll zoom 9. Zoom 0, I'm sorry, zoom fit. You could zoom 9 if you turn on your stat plot, but I really just care about this blue curve here. So yeah, I see some sort of a parabola that looks like this. Okay. If you're not sure of where 16 would be, you can do second trace value. 16, have it point to you where that is. Okay, that's about here. And then we went to 26. Okay, that's about down here, right? So here's 16. Here's 26. 30 is like somewhere right here. So here's where the quadratic says 30 should be. But if you were to connect a line between these 2 points, average rate of change, then 30 would be way up here. So let's see what the quadratic says A of 30 should be using the model. So y1 of 30. It only comes out to 88.556 compared to 274.6. So for this, I would say the model gives a lower approximation for A of 30. Why is that? Because near t equals 30, the quadratic model is lower than the line, or we could say than the linear model. Explain about domain and range. Okay, so domain and range, again, you should always be graphing the model to see what domain and range is. So it's not explain why they should be limited. It's saying find the domain and range. They should be limited. They're not all real numbers, so explain what they are. So you could do a little bit of an explanation. So what about x is the dimension of a rectangle, right? So x is like the length of a rectangle. X must be positive, can't be 0. But it also needs to be limited to what x values give us positive areas. So x must be positive and create positive areas. Now, I don't think you have to actually explain that, but that's my explanation for what I'm about to do. I'm looking at the graph, and maybe I'm going to zoom it out because I don't see where where the graph hits 0. So let's change the window to be like 0 to 50. There we go. So I can see where this graph starts and stops. So let's find, let's see, do I have the line y equals 0? Let me get this y2 out of here. I have the line y equals 0 in there. Oh, but my window, I'm going to bump my window down a bit so I can see it better. Okay, so I can see the intersection point on there. Let's find those 2 zeros to see what those x values should be. So let's find the first one, get our cursor closer to this side. 9.467. I'm going to write this down for a second. 9.467 to, what's the other one? Get your cursor over the maximum. Enter, enter, enter. 31.298. 298. Now, we need to bump this out. We're talking about lengths of x. To be safe, we should round to a whole number. A lot of times, context of the problem will force you to do a whole number, like number of ice cream cones is what we've had before. So let's round this down to just 9. And let's round this up to 32. And that could be our like encompassing our values here. Although if I round this down to 9, I guess technically I'll have some negative areas. So maybe I will say, maybe we'll bump this one up to 10, just to say, well, that's going to give you a little bit of leeway here. Or if you're not going to round that, take this out to its full decimal, 9.467, whatever it actually was. And then I would round this up to, maybe we'll round this one down as well, or keep this one to its like to 31 because I don't want to go negative. So maybe I'll keep that at 31 or use full decimals. The example I picked was a little bit iffy. If we're talking ice cream cones, then you use your whole numbers.